If f of x equals the square root of x, find a formula for f prime of x, for the derivative of x. So what we need to do is use the limit definition of the derivative. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So what we need to do here is we need to plug in the specific function that we're working with, which is f of x equals the square root of x. So here, this is going to be the square root of x plus h minus the square root of x all over h. Now we have a trick that we can use when we're dealing with a limit and we've got a difference of two square roots. We can multiply the top and bottom of our expression by the sum of those square roots. So we're going to multiply by x plus h, the square root of x plus h, plus the square root of x, in the top and in the bottom. The reason that we do this, you'll recall, is that when we've got a difference times a sum, that gives us the difference of two squares. When we multiply things out, the products of the outer and inner terms are going to cancel, and we're going to square the first term and the last term, and squaring those gets rid of the square roots. And what's going to happen is we're going to have some cancellation, and we're going to be left with an h that we can cancel with that h in the denominator. So let's go through and deal with that difference of squares in the numerator. The first term squared, the square root of x plus h squared, the square root and the squares cancel, giving us just x plus h, minus the last term squared, again gets rid of that square root, and we're just left with x. And then in the denominator, we have h times the sum of those roots, root x plus h plus root x. Now in the numerator, that positive x and the negative x are going to cancel, and we're just going to be left with h, which is really lovely. So the limit as h approaches 0 of h over h times the sum of those square roots. And then we can see that the h's are going to cancel in the top and bottom. And of course, h is the same as h times 1. So we're left with a 1 in the top. So we have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And now we can actually use direct substitution, because when we plug in 0 for h, that's just going to become the square root of x down there. So we've got 1 over root x plus root x. And of course, anything plus itself is 2 times that thing. So this is going to be 1 over 2 root x. And that is the derivative of the square root of x.